Hey, what's up everybody? This is Josh from The Audio Programmer, and we're thrilled to announce this new video series we're doing in partnership with Native Instruments on building your own creative audio tools using Kontakt. If you don't know anything about what Kontakt is or how to get started, this is the perfect video for you. In this first video, we're going to build our first Kontakt instrument together. I'll also provide an overview of the Kontakt platform along with a first look walkthrough of the core concepts. And if you don't have any experience with Kontakt or audio programming in general, don't worry. Just follow along with me and I'll explain all the important parts along the way. Kontakt is an industry-leading platform for creating, playing, and customizing software instruments, synths, audio effects, and MIDI tools. Used globally by thousands, it's become an essential tool for composers, producers, and sound designers. It's widely used in music making, film scoring, game audio, and more. It's deep, but it's also accessible, so you can start simple, then explore more features as you progress. Here's a little about the benefits of using Kontakt. 1. It's easy for beginners and powerful for experts. One of the biggest benefits is that you can get a playable instrument within minutes, coupled with the flexibility to customize deeper as needed. It can be as easy as dragging and dropping some samples into Kontakt, then using Kontakt's extensive high-quality signal processing library as powerful building blocks to customize your instrument. This library includes top-tier effects from throughout the NI collection, including RAM, replica, reactor filters, tape saturation, convolution reverb, and much more, all built directly into Kontakt, eliminating the need for third-party plugins. Once you have customized your instrument to your liking, you can use Kontakt's built-in graphic widgets to design your user interface. As you look to customize your instrument further, you can go deeper with the Kontakt script processor and Komplete UI to give you the flexibility you need to bring your vision to life. We'll be talking more about those later in this video. 2. Maintenance free. Another huge benefit is that NI handles all the maintenance for Kontakt, so you don't have to worry about updates and breaking changes. This means that you can rest assured knowing that anything you build will be compatible with all the current operating systems, major plugin standards, and DAW hosts, both now and in the future. 3. Release via the Kontakt ecosystem. Once you've finished building your instrument, the Kontakt ecosystem offers a powerful path to discovery. Kontakt is used by thousands of creators looking for new inspiration, and when you build with Kontakt, your instrument becomes part of this vibrant creative network. You can release your product independently, or if you want to reach an even wider audience, apply for Kontakt player licensing. More on this later in the video. 4. Extensive support. And if you get stuck, there are many resources available to help you. Along with extensive documentation, you also have access to the NI forum, NI Slack workspace, and community Discord servers as well. You can easily connect with other Kontakt builders and learn from one another. 5. Hardware integration via the Native Control Standard, or NKS. What if I told you that you can configure your Kontakt instrument to work seamlessly with hardware devices? NKS allows you to integrate Kontakt instruments with NKS-compatible hardware, making it easier for musicians to interact with your instrument using physical controls. This not only enhances the user experience, but also makes your instrument more attractive to a larger audience. I'll be showing you how to do this in a separate tutorial. Now, let's dive in and build our first Kontakt instrument together, explaining the key fundamentals along the way. Before we dive straight in, I wanted to give you a brief overview of a Kontakt instrument. Kontakt instruments consist of 3 layers. The first is called the instrument editor. This is where we'll start building our instrument by adding samples and creating the playback behavior. This is the core of what we want our instrument to do. The second layer is called Komplete UI. This is Native Instruments' new visual framework that we'll use to create the graphical user interface that people will see when they're using your instrument. The third layer is called the Kontakt Scripting Processor, or KSP for short. This is where we'll connect controls from our instrument editor with the visual elements that we've created with Komplete UI and bring our instrument together. Okay, so now we're in Kontakt, and the first thing we need to do is create a new Kontakt instrument by clicking on File in the menu. The first option should be New Instrument. If that option isn't available, then Kontakt is in default view and we need to switch to classic view. The way you do this is by clicking on the View menu. The first option here allows you to switch between default and classic view. Switch to the classic view here. Now, when you click on File, you should see the option for New Instrument. Go ahead and click on that. Now, you'll be taken to this new view with your brand new Kontakt instrument. Now that we have an overview, we're going to start off with the instrument editor, which is the core of our instrument. You can access the instrument editor by clicking on the wrench button here in the top left. In this tutorial, we're going to create a simple sampler instrument from some samples I recorded from a toy xylophone. If you'd like to follow along with me, you can find a link to everything you need in the video description below. The view that you see first when you open the instrument editor is the Effects and Modulation section. We'll come back to these a little bit later. Along the top of the instrument editor, you have 5 tabs: Instrument Options, Group Editor, Mapping Editor, Wave Editor, and Script Editor. Now it's time to dive in and put some samples into our instrument. We can do this by opening the Mapping Editor section. The Mapping Editor is where we assign or map samples to specific keys and velocities on our keyboard. And before we go forward, let's discuss some terminology around key mapping so we're all speaking the same language. A zone refers to a sample placement and what keys and velocities they apply to. A key map is a collection of all the zones. Now, with that being said, let's talk about how to get some samples into Kontakt. First, let's open the folder with our samples. Here are 8 samples I've recorded from a toy xylophone. You can see more on how I recorded the xylophone in a separate video in the video description below. This is a simple instrument with only 8 notes that I've recorded at one velocity. The first note is at a low C and goes up to a C 1 octave higher without the black notes. One quick note. Notice that all the samples are being named using the same naming convention, which in this case is number underscore name of instrument underscore note letter and number. You can use whatever convention you like, but the key here is to keep your naming consistent. This is especially important as you start recording larger sample sets. Here are the notes. Now, one thing that I love about the flexibility of Kontakt is how you can map samples in different ways. I'll show you a few different methods that you can use to do this. The first method to key mapping is mapping one sample to multiple keys. Let's take the first sample and drag it from the window and hover it over the mapping editor without dropping it. The highlighted area indicates the number of keys that the sample will map as you move the sample up or down inside the mapping editor window. As you move it towards the top, Kontakt will map your sample across multiple keys and by default, pitch the sample up chromatically from the root note of the sample. As you hover the sample towards the bottom of the editor, this mapping will happen for a decreasing number of keys. Let's drop this sample on note C1 towards the top, where Kontakt will map this single sample over about 1 octave. Now that I've dropped the sample, you can see the active keys for the instrument highlighted in blue at the bottom of Kontakt. Let's play the active notes. As I mentioned before, Kontakt by default pitches the sample up chromatically from the root note of the sample. The yellow box in the mapping editor is the sample zone. I can change the number of keys this sample zone applies to by moving the edges of the zone left or right. As I drag the zone to the right, you'll notice that if I play the keys, the pitch gets higher, but the sound also gets shorter. If I drag the zone out to the left to cover the lower keys, the sample will get longer. This is because Kontakt needs to play the sample faster or slower to accurately replicate the pitch. The further you are away from the root note of the original sample, the less quality that you'll hear from the sample itself. This is something to take into consideration when you're creating sample sets. However, there is a solution for this. In the source section below, we have an option to change back the playback mode. Currently, the mode is DFD, which stands for Direct from Disk. There are several playback modes that allow us to retain the timing of the sample while pitch shifting. I'll talk more about these a little bit later, but for now, we'll keep the mode on DFD. By the way, if I wanted to turn off Kontakt's key tracking, I can do it here by turning tracking off. Now you'll hear the same pitch across all keys. Now, let's delete this sample from Kontakt by clicking on it and pressing delete. In the first example, we put one sample on multiple keys. In this example, we'll assign multiple samples to one key. Before we start, let's go ahead and zoom in a little bit on this mapping editor for more precise editing. You can do that by going to the bottom right and pressing the plus arrow. Let's take sample C1 and drag it onto note C1. Now let's take sample E1 and drop it onto the same key. If we play this key, we now have a harmony of C1 and E1. I mentioned earlier that changing the zone of the sample left or right decreases or increases the active keys the zone applies to. But did you know that you can also change the active velocity mapping of a zone by dragging the top and bottom of the zone up or down? The velocity is how hard you press on the key. The heavier the press, the higher the velocity. And you can see the velocity from the red line that appears when you press a key. Let's set sample C1 to trigger for lighter velocities and sample E1 for higher velocities. Now, when I press the key at a lower velocity, you'll hear note C1, and when I press the key at a higher velocity, you'll hear sample E1. This is handy when you're recording an instrument where you may need different samples to demonstrate different velocities, such as a piano. When you hit a key softer or harder, the difference in the piano is more than the volume. The actual timbre and sonic characteristic of the piano key changes. Kontakt's flexibility to play different samples based on velocity gives you the ability to create a more expressive and realistic instrument. In our first example, we demonstrated one sample to multiple keys. In our second example, we demonstrated multiple samples to one key. And in this third example, we're going to demonstrate multiple samples on multiple keys. What we're going to do is drag each sample individually onto its corresponding note. Now, one thing that you'll notice is that if you look at the note numbers, that we don't have any sharps or flats. So this is only the white notes, none of the black notes in this scale. So let's go ahead and drag these samples onto the corresponding notes. Now, as I mentioned before, we don't have any active notes for these black notes, that is the sharps or flats. But one thing that we can do here is use Kontakt's key tracking to help us fill in those black notes. So I'll drag out the zones of the preceding key so that this entire octave is filled in with active notes. Now we have our first playable Kontakt instrument. Now feels like a good time to save our instrument to keep our progress safe. Go up to the top menu to File. Go to Save Edited Instrument. Be sure not to go down to Save Multi-As. That's something different. Save Edited Instrument, As you can see, there are some options on how we can save our instrument. First, there is the patch only option, which will create an NKI file. This is the file that holds the settings and configuration for the Kontakt instrument on its own. The second option, patch plus samples, is the same as the first, but also copies the samples themselves into the same directory as the NKI file. The third option, monolith, embeds the samples into the NKI file as a monolith file. I personally recommend creating a new folder for your instrument and choosing patch plus samples. So let's do that now. We'll create a new folder. Let's call this Toy Xylo Kontakt. Now we will save the instrument. We will call this Toy Xylo. What this will do is create an NKI file and a separate folder in the same directory for your samples, keeping things organized. The first option of saving the NKI file means that you'd need to relocate the samples if you move them later, which can be a hassle. A monolith packs everything into one NKI file, which is convenient but limits you from adding or editing samples later, so I would avoid it unless you were packaging this as a final product. Now let's open the folder quickly, and you can see that we now have the NKI file and a new folder where our samples are stored. So we can take these original samples and move them elsewhere if we wanted to, and it would not affect the instrument. Before we finished with the mapping editor, I wanted to talk a little bit about the source section. As I mentioned before, this is an area where you can completely change the sound of your instrument just by experimenting with this section. This is not exhaustive and is beyond the scope of this tutorial, but here are just a few of the cool things that you can do. As I mentioned before, Kontakt has several types of sampling algorithms that can help you shape and add character to your instrument. I'll describe these briefly. The first playback mode is the sampler mode. This mode is best for traditional sampling and probably the best option for our instrument. In our instrument, we don't have many samples, so these can be loaded directly into our RAM for immediate playback. The second mode is DFD, which stands for Direct from Disk. This refers to streaming directly from the hard disk drive, rather than attempting to load your samples into RAM. This is best for very large sample sets, such as if you were creating a richly sampled 32 gig piano library. Kontakt is one of the only samplers on the market that allows direct from disk streaming, and that's one of the things that have made it so powerful over the years. The third mode is wavetable mode. Did you know that Kontakt can be used as a wavetable synth? Yes, you can load your own wavetables into Kontakt and use the wavetable mode to create your own synthesizer. Some examples of libraries that have been made this way include Conflux, Leap, Analog Dreams, and more. The next four playback modes, Tone Machine, Time Machines 1, 2, and Pro, all use time stretching algorithms to help keep the duration of the sample constant regardless of the pitch of the original sample. So if you have an original sample and you're trying to pitch it far up or down the key range, then one of these modes is probably ideal for you. Tone Machine uses granular synthesis to accomplish this, while the Time Machines use other methods. Experiment with these to find the best results for you. Beat Machine is ideal for dividing rhythmic loops into slices that are mapped to keys, while the S1200 and MP60 algorithms are designed to keep the character and sound of classic vintage samplers. You can also use the tune parameter to tune your entire instrument up or down and use the reverse button to reverse your sample sets. As I'm sure you can see, you can go much deeper with the mapping editor, but this is designed to help you get started. Now let's make this instrument even more amazing using the group editor. Let's open the group editor by clicking on the group editor tab here at the top. We can also now close our mapping editor by clicking off of it. Groups are a way that we can batch organize our samples and customize them. This is how we can use Kontakt to build extensive libraries that use sample groups for different articulations, mic positions, velocity layers, and more. As you can see, we already have Group 1 created for us. Let's duplicate Group 1 by right-clicking on the group and selecting Duplicate. When naming your groups, you may want to consider names that are more intuitive, but since we're going to be changing effects throughout this tutorial, I'm going to keep the names simple as Group 1 and Group 2 for now. Now keep in mind that I created this group by duplicating Group 1. This means that all the samples I had in Group 1 are now in Group 2. If we have wanted to create a new group with no samples, we can select Create Empty Group at the top right of the group editor. By default, the Edit All Groups button is currently enabled. This means everything that I do for one group will apply to all groups. For example, let's reverse the samples using the Reverse button in the Source section. Now, let's enable Group Solo in the Group Editor. This allows us to select and audition one group at a time. We can solo between the groups by clicking on the groups themselves. Now you'll see that when I flip back and forth between the two groups, they still sound the same. So here's Group 1, and here's Group 2. Now, let's select Group 1, disable the Edit All Groups button, then turn off Reverse Playback. Now we'll play Group 1 and play Group 2. And we can hear that Group 1 is playing forward and Group 2 is now playing backwards. The question is, how can we flip back and forth between these groups without the need to group solo? I'll show you two ways in this next section called Group Start Options. To start, let's unselect Group Solo. Now, when I play a key, you'll hear both Group 1 and Group 2. One sample will be playing forward and the other backward. There are a few ways that we can give the user the ability to switch between groups. Let's click on Group Start Options. Here are the options that we can select from. Always is the option that's currently enabled, where the group will always trigger when we press a key. Start on Key. Here we can create what is called a key switch. This is where we can press one key to enable Group 1 and a different key to enable Group 2. Let's give this a try. First, we'll make sure that Group 1 is selected and that we have the Group Start option on Key selected. Now, key C0 is our key switch. This means that when the user presses key C0, this will switch to Group 1. We can tell that this key switch is active if we look down at the very bottom of Kontakt because we see the red key on key 0. The red key indicates the key switch. Let's do the same for Group 2 with a different key. We will select Group Start Options, Group Starts on Key. Now we will change this to a different key. Let's make it D0. Now this means that when I press C0, that this activates Group 1, playing the samples forward. Now when I press D1, this will deactivate Group 1 and enable Group 2, so the samples should be playing backwards. The next option is Start on Controller. This is where we can use a MIDI controller value, such as a button press on a MIDI controller to achieve the same effect, but we won't worry about that for this tutorial. Cycle Round Robins is the next option. Round Robin is the name for a technique that is normally used to play sounds that have a slight variance to give our instrument some life. There are a number of reasons we may want to do this, but one of the most common is to record multiple samples of an instrument at the same key and velocity to prevent a machine gun type of effect that comes with playing the same exact sample at rapid succession. In our sampler, I only have one sample I can trigger when I hit the note C1, but I could cycle between groups to create some variance. To show this, let's have some fun. First, let's select Group 1. Then we will change Group Starts to Cycle Round Robin. Let's keep the position in Round Robin chain to 1. This will become apparent why later on. Now let's switch to group 2 and switch the group starts option also to round robin. Let's change the position in round robin chain to group 2. Now let's go to the source section. Bear in mind this is the source section for group 2 because group 2 is currently selected. Let's turn off reverse. Now let's turn up the tuning. If I press Shift and click, then this will do fine tuning. Let's turn it up so we can hear this effect. We'll turn it up to about 0.4. Now let's press the C1 key. You will hear the sample play first from group 1 because that is in round robin chain 1. Now if I press it again, it will cycle to the other sample from group 2 with the different tuning. Each time you press it, it will change to the sample from the next group. Now you have round robins. This is a predictable way that we know what sample is going to play next. For this type of use case, we may want a little bit more unpredictability. We can do this using a variant option called Cycle Random. Let's enable Cycle Random for both groups now. This creates the impression of an instrument that slides in and out of tune. You can take this even further by creating more groups with slightly varying tunings, cycling randomly between them. The final option, Slice Trigger, applies more to loops and is beyond the scope of this tutorial. Before we move to our next section, let's change our group start options back to key switches. The way that we do this is select one of our groups. We'll select group 1, switch it from random to start on key. Make sure that group 1 is set to switch on key C0. Now we'll select group 2. We'll change group start options from random to start on key. And let's make sure that this is set to D0. You'll know if you are set up correctly if you look at the keyboard at the bottom and you have key switches in red for C0 and D0. Next, we're going to cover the effects section. Kontakt has a massive library of audio effects that allow us to shape, enhance, and polish our instruments from within Kontakt without the need for external plugins. There are 4 types of effects. The first is the group insert effect. This is an effect that we can apply to one or a set of groups. Some examples of ways this is typically used include different articulations, mic positions, or round robins. When you apply a group insert effect, this would not affect other groups. Let's take a look at a quick example by applying a group effect to group 2. First, I will make sure that I have group 2 selected. Then I will go to the group insert effects section and click add effect. Let's go down to lo-fi. Now I will select lo-fi. Now we can use our key switches to change between the ineffective clean sound and a bit crushed lo-fi sound. Here is the clean sound. And here is group 2, which is the lo-fi sound. While I'm here, there are a few other things to keep in mind in your design. The first is that group effects are polyphonic, which means that the effect is applied per voice, not per group output. So if I press 2 keys at once, that means that the lo-fi effect is being applied per key, not per group output. Just something to keep in mind. Also, modulators, which we'll talk about later, can only be applied to group effects and not to any other type of effect. Next, let's talk about instrument insert effects. We can find the instrument insert effects section by scrolling down. These effects apply to the entire instrument. Think of them like a global effects rack. Some examples of typical usage may be a master compressor to unify the sound or a reverb to apply some space to the entire instrument. Let's apply an instrument effects now. Scroll down to reverb and select RAM. While I'm here, one thing that you'll notice is that options between different types of effect groups may be slightly different. For example, you'll see if I go back to the group effects that we don't have any options for reverbs. As we scroll down to look at the parameters for RAM, we'll see that we also have parameters that we can tweak to our liking. Let's go ahead and give it a test. This is a little bit too much reverb for me, so I'm just going to turn this down to about 30%. And now we can hear that this effect applies to both groups 1 and 2. The third level of effects in Kontakt is the instrument send effects section. This is an effects chain that is shared across all groups where we can apply differing amount of effects to the groups, or alternatively, we can add the send to the instrument level. For example, let's say we were making a string library. We may want the staccato strings that are short to have less reverb than our longer legato strings to simulate how our room space might behave. Let's take a look. I'm going to add a cyc delay effect to the instrument send effects section. One way that we can add this send effect is on the instrument level via the instrument effects section. This would affect both groups. Let's go to add effects, scroll down to utilities, and then send levels. Now we have the cyc delay as a send on the instrument insert effects section. If I wanted to apply this to the group level, I can take this off of the instrument insert effects section and go up to the group level. Let's apply more of a cyc delay to the group 2, which is the lo-fi group, than group 1. So once again, on the group insert effects section, I scroll down to utilities, down to send levels. And now let's test what that sounds like. Let's give it a little bit of feedback and let's pitch it up a little bit. Now let's apply the same effect to group 1, but we don't want as much of an effect on this one. So once again, we go down to the group insert effects section, make sure that group 1 is selected, and now we'll add the effect, scroll down to utilities, to send levels. And what I can do is I can turn this effect down so that we barely hear it. And now we can switch between group 1 and group 2 to hear the difference. Hear how we have a lot more delay on group 2, then back to group 1. It's just very slightly. So this is a way that we can take an effect and send it in differing amounts to each group to adjust to our tastes and needs. Finally, we have the instrument main effects section. This is very similar to the instrument insert effects section, but think of this more like your master bus where you can apply any type of final limiting, compression, or EQ. For this example, let's add some wow and flutter to give the instrument a little bit of character. Let's turn up the wow a little bit. This is off. This is on. I'm going to turn down the mix just a little bit. Group 2. That sounds pretty good to me. Let's add a limiter. As you can see, we've just touched the surface of what we can do with effects within Kontakt. I invite you to experiment even further with these effects to make this instrument your own. Now let's talk about modulators. Modulators are a way that we can control and shape a parameter over time, making our sound more expressive and dynamic. Looking at the bottom of our instrument editor, we can see that we already have one modulator, an envelope that shapes how our volume fades in and out when we press a key. If I change the attack, it changes the shape of the sound. Another way that we can apply modulators is to group effects. Let's take a look. Let's scroll up here to our group effects section. Currently, we're on group 1. What we can do is we can add an effect. Let's add a filter. I will go to low pass and let's add the Pro 53 filter. So now we have a filter cutoff, and let's go ahead and modulate this. What we can do is we can right click. Let's select an LFO and assign LFO. This means that we can shape the filter cutoff over time with the sine wave LFO. Now what I can do is I can go down to the bottom. The way that I go down to the bottom is by clicking this arrow here. This will take me down to the bottom, and here I can adjust the sine wave. Let's make the frequency a little bit faster. That feels better. We can go back up to the group by clicking on this arrow. And here we can change the amount that we want this LFO to affect the filter cutoff as well. So currently it's at 100. If we switch it down to 0, then it doesn't modulate it at all. So let's go ahead and put that at 100. Let's add a little bit of resonance. That feels pretty good to me. As you can see, this vastly changes the shape of the sound, and you can get some very creative effects, especially if I start playing with the resonance. Let's do the same to the resonance, but with an envelope rather than an LFO. First, let's right click on resonance. Let's select AHDSR envelope. And now, if we turn the resonance down a little bit. Now that's a little bit too fast for my liking. Let's make this a little bit slower. So as you can hear, now I changed the attack of that envelope, and now it's adding resonance that's going over time. These two examples should help give you a starting point, and there are many others. One other note is that the modulation options will depend on the effect that you select. Experiment and shape your sounds. Now we're finished building the core of our instrument, and we're ready to move on to building our own custom user interface using Komplete UI. If you've built instruments in Kontakt before, you'll know that the user interface was traditionally created using KSP, which stands for Kontakt Script Processor. This meant slicing up bitmap images, managing film strips, and hard-coding control positions. This approach to UI building still works, but the evolution of user interfaces and high-definition displays have created a need for a new solution. This solution has now arrived with Komplete UI, available in Kontakt 8 and above. Komplete UI is a modern UI framework built from the ground up for modern Kontakt instruments. This replaces the older KSP-based interface workflow, which is now considered a legacy method, still supported but not recommended for new development. Komplete UI is designed to make building user interfaces faster and easier while keeping your instruments looking sharp on modern displays. Here are two of the many benefits of Komplete UI. 1. Modern scalable UI design. Komplete UI marks a big shift from static graphics to a fully programmable dynamic visual system. Now, you can create responsive, customizable controls directly in code. No more prepping film strips or individual image assets. Whether you're building a UI programmatically or incorporating custom visuals, Komplete UI gives you the flexibility to work the way that you want. It supports modern vector graphics, including SVG, so your interface looks crisp on any screen, from standard displays to 4K and Retina. And if you still prefer using traditional assets, Komplete UI supports a range of image formats like PNG, JPEG, WebP, and TIFF. You're in full control of how your UI is built, and it'll look great on any resolution. 2. Clean modular workflow. Komplete UI introduces a clean separation between your visual interface and the logic that powers your instrument. You can use Komplete UI to lay out your user interface, defining the controls, layout, labels, and visual hierarchy. Then you use KSP to wire those controls to the underlying instrument behavior, controlling filters, envelopes, playback modes, and more. This separation makes your development process faster, more modular, and easier to maintain, especially when working as part of a team or scaling up to larger projects. Now, let's dive in and I'll help you get set up with Komplete UI. Before we start, we're going to need to do some downloading and setup. This may look a little daunting if you're just starting out, but don't worry, I'll be taking things slowly. Just follow along with these easy steps and everything will work out fine. The first step is to download Microsoft's Visual Studio Code. This is where we'll be writing our complete scripts. It's a free download available for both Windows and Mac, and I've created some separate videos on how to download and install this, so please see the video description for more information. Next, download the Komplete UI extension from the Native Instruments website. The link is in the description as well. Think of this extension as a plugin that will allow us to get helpful tools for writing our complete scripts, such as syntax highlighting and documentation when we hover over Komplete UI keywords. The third step is to install the Komplete UI extension in Visual Studio Code. First, we'll open up Visual Studio Code, and on the left sidebar, we will go to the Extensions tab on the bottom left. Now we will go to the three dots in the top right-hand corner, and we will select Install from VSIX. Locate the VSIX extension that you just downloaded and click Install. Once this is done, you should see a dialog in the bottom right-hand corner that says Completed Installing Extension. To make sure that this installed correctly, just search for Complete in your extensions and you should see Complete Script. The next step is to return to Kontakt, and let's go to the Kontakt settings by going up to the top left and clicking on Settings. Now let's go down to the Developer tab. We want to enable Developer Mode. This option will allow for additional logging and making sure that our images are being updated on the fly and refresh automatically as we change the complete script. Next, let's set up a resource container for our instrument's resources. The resources are where we'll store any images, scripts, and other assets that we create for our instrument. In Kontakt, first open the instrument editor. Then click Instrument Options. Then under Instrument, we want to create a resource container. Let's set this folder in our project folder, Toy Xylo Kontakt, and we will call this folder Resources. Select Save. Now we'll get a dialog that says Resource folder was not found. Do you want to create one? Click Yes. Now we should get another dialog that says a resource container was created. Click OK. Now let's take a look at what happened in our project folder. There have been a bunch of new files that have been created, but we don't need to worry about these other files for now. The most important thing is in the resources folder, we have a folder called Complete Scripts. This is where we will write and store all of our complete scripts that we write with Visual Studio Code. We're nearly ready to start coding. Let's go to the Explorer that's on the top tab on the left. Now let's go to a folder. Click File and click Open Folder. Now we want to navigate to the folder where our complete scripts will be stored. So go to our project folder, to Resources, then to Complete Scripts, and select Open. In Complete Scripts, let's create a new file. Click on New File. It's important that this first file is called main.kscript. This file is called a module. All kscript files need to be within the Complete Scripts folder within the resource container. Only one more step and we'll be ready to code. Let's go to Kontakt to the instrument options. In here, you'll see a Complete UI section where we need to point Kontakt towards our main module. Go to the folder within the main module and that will open up our Finder. And we just need to locate the main.kscript file. Click Open and we're finally ready to start coding. Complete UI is already installed as a library that came bundled within Kontakt, so now we just need to make some commands to interact with it. Let's take a look at the Complete UI documentation to find out how. As we can see, there are several libraries that have come with Complete UI, and one of those is the UI module. Let's go ahead and click in here, and then click in Components, and we can see different types of components that we can draw for our user interface. Let's go to the text component. This displays text on our screen. Let's copy this code and let's paste it into our kscript and see if we get some text that says hello world on our screen. By the way, don't forget to hit save on your kscript or else you may not see any changes on your user interface. Let's close out the instrument editor. And now we can see that we have created our Complete UI user interface that says Hello World. Let's take a look at how quickly this refreshes. We'll shorten this down to Hello. And wow, that refreshed within a second or two. So we can see that as we're drawing more components on our user interface, that we'll get some real-time feedback to be able to make our user interface pixel perfect. Before we move to the next section, we have one more thing that we should do. On the Native Instruments developer website, they have a set of contact controls. These are visual components that we would commonly use for a user interface, like buttons, sliders, and knobs. Let's go ahead and download those. I'll put the link in the description below. Next, let's unzip the folder. Open the folder, and here we can see that we have some more kscripts. These are for visual components such as knobs, switches, toggle buttons, sliders, and so on. Since these are kscripts, we need to put them in the kscript folder that we have in our project. Let's open up our project, go to Resources, Complete Scripts, and let's take Contact Controls and put them in with our main.kscript. We'll come back to these a little bit later, but for now, we're done. Now that we have Complete UI set up, we will briefly move over to the Kontakt Script Processor, or KSP for short, to create some parameters for our instrument. These parameters, such as volume or filter cutoff, are the controls we want our users to interact with. After creating these parameters in KSP, we'll return to Complete UI to build corresponding interface elements such as sliders or knobs, and finally connect them to our parameters for a seamless user experience. Kontakt Script Processor, or KSP for short, is Kontakt's built-in scripting language that defines how your instrument responds, behaves, and performs. Here are just a few of the many things you can do with KSP. 1. Connect UI elements to parameters. Use KSP to link sliders, knobs, and buttons to engine parameters like volume, filter cutoff, envelope settings, or anything else your instrument needs to control. 2. MIDI event processing. You can use KSP to intercept and transform MIDI data on the fly, from remapping notes and velocities to creating custom articulations or scripting intelligent note behavior. 3. Customize playback behavior. Create unique performance responses, legato transitions, phrase playback, round robins, randomization, and dynamic sample switching, all made possible through KSP. 4. Create user interfaces. This may be a surprise for new users, but in the past, KSP was used to build the visual interface of Kontakt instruments, placing controls, assigning images, and laying out panels. However, with the introduction of Complete UI, this part of the workflow has moved to a more modern and visual design environment with Complete UI, leaving KSP to focus on behavior and logic. Now, let's jump into KSP and I'll show you how to get started. The first step to scripting with KSP is opening the script editor in Kontakt. The script editor is the last tab in the instrument editor. Let's open that up. Press the Edit button to open up the text editor within the script editor. As with Komplete UI, you can use an external text editor to write your scripts, but I want to keep this tutorial simple, so we'll just be writing our script right here in Kontakt and referencing the KSP manual from the NI website. If we close out the script editor and go back to our instrument, we can see that we have a Pro 53 filter that we have assigned to Group 1. Let's see if we can make the Pro 53 filter cutoff a parameter that's controlled by a slider in our Komplete UI. I'm going to make this even easier for us later on by switching the Pro 53 to the first effect in our group signal chain. Now let's return back to our script editor. Here's an overview of what we're going to do. First, we'll use KSP and Komplete UI together to create a slider. Then, we'll figure out how to access the filter cutoff parameter from our instrument. Finally, we'll use KSP to connect the cutoff parameter from the instrument to the slider. So when we move the slider, it changes the filter cutoff in the instrument. Before we start writing any code, let's write down what we want to do in plain language. This is a great habit for any programmer, and I use this method all the time. Let's think of coding as an event-based recipe. It often starts with, when something happens, I want something else to happen. So based off of this simple logic, we could start with something like, when the program starts, create a slider called filter cutoff between the values of 20 and 20,000. I picked those values because those are the typical frequency values for a filter cutoff. Then we could say something like, when the filter cutoff changes, I want to update the filter cutoff from the slider value. Now, let's do the same process again, but make our pseudocode a little bit more code-like. It may look something like this. When we start the instrument, we're going to create a slider that's going to be called filter cutoff. We're going to have some function that I've just made up in my mind called create slider. And then the name of the slider is going to be called filter cutoff, and it's going to go from a range of 20 to 20,000. Then we might write something like this for when the filter cutoff changes. When the filter cutoff changes, run some function called update. And the parameter we want to update is the Pro 53 filter cutoff. And we want that to have the value from the filter cutoff slider. Now, I will say that I've had the privilege of having already worked this out in advance. So the way this will play out will be quite close to what I put here. However, I find that this type of thinking out loud and writing it down helps me convert my intent into the code that I'm going to write. With that being said, let's go over to the KSP documentation and see if we can change our intent to actual code. As with what I described earlier, everything in KSP is event-based. This means that we need to describe what we want to happen based on some type of change that we see in the instrument. The way this is done in code is called a callback. Let's take a look at the callback section in KSP. One thing that I'll say is that it's very important to read the documentation. Many times there are nuances to be aware of. In this case, we can see that any callback needs to start with an on callback name and end with an end on command. One of the most common callbacks that you'll see anywhere in coding is when your application or your instrument starts. Typically, this will involve initializing some type of resources and setting values. If we take a look at our callback list, we can see that we have a command called onInit. Let's take a look at that. As you can see, this is an initialization callback that is called when an instrument is first loaded. So what's really nice about this documentation is that we have a coding example that we can look to. So we have this onInit command. Then we have a whole bunch of code. This can look very daunting, but don't worry about any of this. The most important thing is that we see this end on down at the bottom to close out our onInit command. So let's go ahead and put that into our code now. All right, here we are back in our script editor. Let's go ahead and take this pseudocode that we made. I'm just going to cut it out of here and paste it over in this text editor here, just so we don't lose it. And now we're ready to start our code. So the first thing that we need is on init, and then right below that we will put an on. Then we will hit apply. And we don't have any errors, so the script has been updated. So we've just written our first KSP code. Congratulations. Okay, let's make this do something else now. Going back to our pseudocode, we've now figured out the when start part of this. Let's see if we can figure out the create slider called filter cutoff between 20 and 20,000. Let's go back to our documentation. Let's go and search for slider. And we will go to this first result called UI slider. This creates a slider, and it takes two arguments, the minimum value of the slider and the max value. What's nice about this example is that we can see that there is an on init example. Let's go ahead and just take this and copy this into our KSP. The convention here is that everything between the start of the callback, which is on init, and the end of the callback and on is indented. So let's go ahead, paste that there. We're going to change test to filter cutoff slider. It has to have the $sign before it, so make sure that you keep that there. I'll just call this cutoff slider. I'm going to change the values to 20 to 20,000. So now we have a cutoff slider. Let's go to the next step. Now I know what you may be asking yourself. You may be asking yourself why I'm declaring a UI slider in KSP when I said that Komplete UI was responsible for the sliders. And you're partially right. The only part that I would add is that Komplete UI is only responsible for drawing the slider. KSP is for describing what the slider will actually do, what the minimum and maximum values are, what parameter it controls, what happens when you change the parameter, and so on. So think of KSP like the brain of the slider. That is what it actually does. Komplete UI is like the face. That is only what you see. In other words, you need to declare the slider in both KSP land and in Komplete UI for the slider to fully work. Now the question you may be asking is, how does KSP talk to Komplete UI? Well, there's a special command that we need to add here called expose controls. Let's go ahead and open the documentation. Expose controls is a special command that makes the UI widgets that I've created in KSP accessible as parameters in Komplete UI. This is the connection point between KSP and Komplete UI. You'll see what I mean shortly, but the most important thing to know for now is just that we need this expose controls command that we can copy here, and we can paste in our on init callback. Let's press apply to make sure there are no errors. And there are no errors, so we're good to go for now. So let's switch over to the Komplete UI documentation to see how to draw a slider. We can see that slider is part of the Komplete controls package. Let's go ahead and click on that. In the example code for slider, we can see that the first command is import slider from Kontakt controls. If we take a look at the Kontakt controls folder that we downloaded earlier, we can see that we have a slider.k script. This is what this command is referring to. The next part, export var main, is just a variable that serves as our insertion point into the drawing code itself. Then we declare a slider. The constructor here in the documentation shows us all the parameters we can use to customize our slider. We can see here that only two are required. The control ID, which needs to be the same as the corresponding KSP control that we created earlier, and the label, which is the text that will display under the slider that identifies it. Let's just copy all of this into our K script for now. Taking a look back at our KSP, we see that the name of the slider we declared was called Cutoff Slider. Let's change my slider to Cutoff Slider. Let's change the label to something more intuitive like Filter Cutoff. Let's go back to our Kontakt instrument and let's close our instrument editor. And now we see a slider. We notice a few things though. First of all, the slider label isn't showing. This is because the label text is white, but the background is also white. Also, the user interface area is very small. Let's fix those. First, let's open up the instrument editor. Then go to Instrument Options. Here we can change the canvas size of our instrument. Let's change the height to 300. We close this. Now we close our instrument editor. And now we can see that our user interface area is much bigger. Now let's get this label showing. For this, I'm going to use a component from our UI module called ZStack. ZStack is a component container, which means that it's able to hold child components and stack them on top of each other. So here we see that we have 3 rectangles. One is stacked on top of the other, and this is the result down here at the bottom. So what we want to do is draw a rectangle, then draw the slider on top of the rectangle. Let's go ahead and do that now. First, we will import ZStack and rectangle from UI. Next, let's take the slider code that we created earlier and move it down a few lines to make room for our ZStack. ZStack is a container, so eventually we're going to have the ZStack hold our rectangle, which is going to draw our background, and then the slider on top of the rectangle. Next, I've created a ZStack with an open bracket and a closed bracket. Everything we want inside the ZStack is going to be within these 2 brackets. Also notice, I didn't create a second export var main. That's because we already have one. We only need one export var. If we take a look at our user interface, we'll see that we don't actually see anything, including our slider. This is because something is wrong. What we need to do is take the slider and put it inside the ZStack. Let's copy this code. Let's place it inside the ZStack. And now we see our slider again. Let's go ahead and indent the slider to make it easy for other people to read. Now we see that we have the ZStack with the slider inside the ZStack. We need one more thing, which is our background. Let's go back to the documentation. Let's take this rectangle and just copy this for now, paste it inside. And now we can see that our background is red and we can see the label Filter Cutoff. Once again, let's go back into our code. Let's indent this and add a space so this is easy to read. And now we have our ZStack, which draws the rectangle, then draws the slider directly over top of the rectangle. Let's test out our instrument. As we can hear, the slider isn't doing anything yet. That is because we haven't done the second part of our pseudocode, which is when the filter cutoff changes, we want to update the filter cutoff from the slider value. Let's go ahead and do that now. Let's open up our instrument editor. Now let's open up our KSP documentation and look for another callback that corresponds with what we're looking for. Let's go to callbacks. If we take a look at our callbacks, we have one that's called on UI control. Let's take a look at this. The documentation says UI callback executed whenever the user interacts with a particular UI widget. So in this case, we want that particular UI widget to be our filter cutoff. If we take a look at the documentation a little bit further down, we see that we have an example where it says we use on UI control, then we need to put inside of the parentheses the parameter that we're listening for. Then we need to end with an end on message. Let's go ahead and do that in our KSP script now. Here is the command that I've created that will listen for changes from the cutoff slider. We start off with the on UI control command. Then in parentheses, we put the UI widget that we're listening for changes from, which in this case is the cutoff slider. Remember to put the $sign in front as well, or else your script won't work properly. Then we finish with an end on command. Now we just need to find a way to update the filter cutoff parameter with the value of the slider. For this part, we need to go to the section marked Engine Parameter Commands. Let's go ahead and open that section now. Now we need a way that we can set the engine parameter for filter cutoff. Let's go to the Set Engine Par command. As we can see from the documentation, it says that Set Engine Par will control various Kontakt engine parameters. This takes 5 arguments. The first is the parameter that we're looking for. The second is the value. The third is the group. The fourth is the slot. And the fifth is a generic parameter. Let's go through these one at a time. The first part specifies the parameter by using one of the built-in engine parameter constants. Let's go ahead and open that up in a separate tab. The engine parameters section contains a list of all the potential parameters that we can access in Kontakt, including all the parameters for effects and modulators. In the drop-down menu here on the left, we can see that this is divided into sections, including filters and EQs, insert effects, send effects, modulators, module types, and subtypes. Let's go into filters and EQs since we're looking for the filter cutoff. As you can see, the first variable, engine par cutoff, controls the cutoff frequency for all the filters. In my KSP script, I've started the command set engine par and set the first parameter as engine par cutoff that I've found from the list of our engine parameters. The second parameter is the value to which the parameter needs to be set. Notice that it says that the range of values should be from 0 to 1 million. So we want to get the value from our cutoff slider, but the values here go between 20 and 20,000. What this means is that we either need to switch the value of the cutoff slider to go between 0 and 1 million, or that we need to do some type of math to take the 20 to 20,000 and scale it up to 0 to 1 million. To keep things simple for this tutorial, I've decided to change the minimum and maximum of the cutoff slider to 0 to 1 million rather than 20 to 20,000. Here I've set cutoff slider as the second parameter within set engine par. The next parameter is the group. It says the index of the group in which the specified parameter resides. Here we can see the Pro 53 filter cutoff is in group 1. The other thing that it says in the documentation is that the index needs to be 0 based. That means that we start off with the number 0 rather than 1. So even though this is group 1, the index of group 1 is 0 and the index of group 2 is 1. It's a little confusing to get the hang of at first, but this is a convention that is very common within coding. The next parameter is the slot parameter. This is once again a 0-based index of the specified parameter. So if we go back to our instrument, we see that the Pro 53 effect is the first in the group insert effects chain. That means that the index of this effect will once again be 0 since it is the first effect in the chain. The last parameter is a generic parameter. It says that the parameter applies to instrument effects and internal modulators. Since we're working on a group effect, we don't need to worry about this. Go down to the bottom and it says, for all other applications, set this parameter to -1. Now we should be ready to test out our cutoff parameter. Let's go ahead and hit apply, see if we have any errors. And we have no errors. Let's go to our instrument view and test our instrument. So now we hear that this filter cutoff is working. Let's do one more parameter together and we'll go a little bit more quickly. This time we're going to adjust one of the modulators, which is going to be the LFO that we have attached to the filter cutoff. Let's see if we can figure out how to adjust the frequency and make that a parameter that's accessible to the user. First, we'll declare a UI slider in our KSP. We'll call this one LFO slider. To keep things simple, I will set the minimum and maximum between 0 and 1 million. Next, I've created another Z stack where I've created a rectangle, which is the color red, and above that, a slider that now has the control ID LFO slider to match with the UI slider that I've declared in KSP. I will call this LFO frequency. One problem though, we need something that will hold both of our Z stacks. If we go over to our instrument view, we'll see that we have nothing showing in our user interface. We need some type of UI component where we can put the Z stacks together, putting the cutoff slider at the top and the LFO slider beneath it. Fortunately, Komplete UI has a solution, which is VStack. It's a component that arranges its children in a vertical line. If we take a look at the coding example beneath it, we can see that there's an example that sets 3 rectangles on top of each other. Let's go ahead and implement this. First, we will import VStack from UI. Next, let's create a VStack as our parent component. Finally, let's take the Z stacks, which contain our cutoff and LFO sliders. Let's cut them and let's put them inside the VStack. Now we see that our UI has updated and we now have our filter cutoff, which is on top of our LFO frequency. Now let's return to KSP and implement a callback that listens for changes in the LFO slider. Next, we start the command set engine par just as we did for the last slider. Now we need the name of the engine parameter that we want to change. To the left in the drop-down menu, we see that there is a special section for modulation. We find the section for LFO modulators and see that there's a parameter called engine parameter mod frequency. The next parameter in set engine par is the value that we get from our slider. Next is the group slot where the engine parameter resides. LFO sign is modifying our filter cutoff in our Pro 53, which is inside group 1, which means that the index is 0, the same as our last parameter. The slot parameter is a little bit different this time. As you can see from the documentation, we need to use a special function for modulators and modulation intensities called getModIndex. Let's go ahead and click into this function. This returns the slot index of an internal modulator or external modulation slot. The first parameter is the group index. This is the same as the index that we had before, which is index 0, since the modulator itself is inside group 1. The second parameter asks for the modulator name. For this, we need to go back to the instrument itself. Let's go to the modulator, which is this LFO sign. We click on this arrow that will take us to the bottom. And then if we right click on the modulator itself, we can see the name, which is LFO_sign, all in capitals. Let's go ahead and add that to our script. The function call is get_mod_IDX. First parameter is our group, which is 0. And the second parameter is the modulator, which is LFO_sign. Make sure that's in quotes. We still have one more parameter for our set engine par command. For the last parameter, if we wanted to get the parameter for this modulation amount, we could do this using getTargetIDX. What we would do is right click here, and this would give us the name of the parameter, which is LFO1. Notice that this is different than if we go down to the bottom and right click on it and we see that the modulator name is LFO sign. So it's very easy to get these two confused. Make sure that you know which parameter that you are trying to modulate. For this situation, we just need to set this parameter to -1. All right, we should be good to give this a shot. Make sure that when you do any changes that you don't forget to hit the apply button, or else your changes won't be reflected in the instrument. Let's go to our instrument view. Let's go ahead and try our instrument. So we'll open up the filter And now we'll try the modulation frequency. So we see that both of these parameters are now working. There are many ways this example could be improved. For example, one of the first things I'd probably want to do is scale these parameters to a more appropriate amount. Currently, both of them are going between 0 and 1 million. But this is a simple demonstration that will help give you the building blocks you need to take your creations even further. Let's use an image to finish off our user interface. Here, Komplete UI has an image class that we can use for this. The first parameter for the image component is an image file path relative to the main file. I'll show you how to find that out right now. First, we need an image. I'm using this tap_logo.png as my image. Second, we need to place it into our project folder. I'm going to put it in Resources, in Pictures. Move the logo there. Going back to our documentation, the parameter is going to be a string that's an image file path relative to the main file. By the main file, it means the main.k script. If we go back to Complete Scripts, click in there, we see that main.k script is within Complete Scripts. So we need to find the path of the image relative to this main.k script. So we will go back a directory. Then we will go into Pictures, and then to tap_logo.png. I'll show you how to do this in Komplete UI. First, let's import image from UI. Next, I'll make another Z stack that has a red rectangle inside of it. You can see how the user interface has already changed from this new Z stack. Now we just need to find the file path relative from main.k script. So we will go back a directory. In code, this is normally denoted by .. Then into the directory where our image is, which is in Pictures. And finally, the name of the image itself. Now we see that our logo has now appeared. However, now that I'm seeing my logo, I want to change the background color. Let's go ahead and do that. We see from the color documentation that a color can be specified a few different ways. One way is the way that it's currently specified, which is using a hexadecimal integer. Another way that this can be specified is using red, green, blue. Since this is more intuitive, I'm going to use this, and I'm going to go for more of a gray color. All right, here's what I've come up with. And as you can see, our logo now has a dark gray background. And I've done this using a different version of color that uses the red, green, and blue as parameters rather than a hexadecimal value. Congratulations! You've now finished your first custom Kontakt instrument. This is a great accomplishment, and I invite you to share your creations. I'm curious to see what you've come up with. Before we sign off, I'd like to tell you a little more about some ways that you can get your Kontakt instrument out to the world. Letting others know about what you've built is just as important as the creative process itself, so stick around just a little longer and I'll fill you in. When you develop with Kontakt, you're tapping into one of the largest sampler ecosystems in the world. Kontakt has tens of thousands of active users, ranging from hobbyists to professional composers and producers. By building your instrument in Kontakt, you're not just creating a tool, you're making it available to a global audience of musicians already familiar with Kontakt's workflow. Whether you release a commercial library or a free instrument, Kontakt gives your creation instant credibility and accessibility within the music production community. You can choose to release your instrument independently, or you can apply to license your product for Kontakt Player to reach an even wider audience. By licensing your product for Kontakt Player, you make it available to both full Kontakt users and free Kontakt Player users, drastically increasing your potential reach. This means your instrument can be installed and used by anyone, even if they haven't purchased the full version of Kontakt. Additionally, Native Instruments offers a partner program, allowing developers to distribute their libraries through the NI ecosystem and even get featured in native access. For developers looking to maximize their impact, Kontakt Player licensing is a game changer. I hope you enjoyed this deep dive into creating your first Kontakt instrument. For more information on how to get started in Connect, be sure to check out the Native Instruments website and the links in the video description below. For now, we're signing off. Happy coding, and I look forward to seeing you again soon.